Hello, everybody. Welcome back to my channel. As you remember, we are doing a playlist on advanced time series modeling, and we have already done Markov switching model and TAR model. And today we will do the vector autoregressive model. However, we should remember that models like the TAR or the vector autoregressive models use OLS for estimating the results. However, given the stylized facts of financial time series data, it is better to use GARCH modeling. So, in the next video, we will see how we can do GARCH modeling and then find the beta in different regimes. When I talk about beta, I'm talking about the CAPM beta, which shows how sensitive is our sector or stock to the market. Okay. So, as we know, our objective is to minimize market risk. So, today we will understand how to analyze from through VAR modeling how shocks in the market is transmitted to our sector, or how shocks in our sector is transmitted to the market. And we need to understand how sensitive our stock is to changes in the market. And on the basis of that, we should take our decision of putting our stock in the portfolio or not. So, we do open as VAR, we do standard var. uh, okay, so this is our first initial results. So we do not yet know what will be the optimum lag structure. To know that, we need to know the lag length criteria. So as you can see, according to FPE, the optimum lag will be 7, and according to AIC, the optimum lag is also 7. So going by majority, I think it's better that we choose the optimum lag to be 7. Like SC and HQ considers the optimum lag to be 0. So if you know, AIC is Akaike information criterion, SC is the Bayesian information criterion, also known as the Schwartz criterion, which is the SC short form. Okay, please ignore the background noise. So we go to estimate, and we include lag structure to be 7. So we have up till 7 lags. So here is our results. However, this is not very important to us. What is more important to us when we are doing VAR is to see how shocks in one system is transmitted to the other system. And to do this, we need to basically construct the impulse response function and to understand how the variance of the sector is decomposed. That is, how much of the variance is coming from the sector itself and how much of the variance is coming from the market. We need to do a variance decomposition function analysis. So this is not very important. Since we're working with volatility, so basic OLS results is not what we are looking for. So now let us go for granular causality tests. So we go to quick, then we go to group statistics, and then we go to granular causality tests. So as we can see, that the granular causality hypothesis, the null hypothesis is that uh, Sensex return does not granular cause IT return, and IT return does not granular cause Sensex return. In this case, the probability is the p-value is very high, higher than 0.1. So we have to accept the null hypothesis. Let's see how is the results if we increase the number of flags. Okay. So here we reject the null hypothesis that Sensex return does not grandeur cause IT return. So as we can see that Sensex grandeur causes IT. However, IT does not grandeur cause Sensex. So as we increase the number of lags, we have come to the conclusion that Sensex does grandeur cause IT. Even this information is not very important. These are all basic information or routine tests that we do while working with VAR. Okay. So now let us go forward for constructing the impulse response function. So we go to view and then we go to impulse response. So we can choose any one of the decomposition method. First, let us consider the residual one unit standard deviation method. Residual unit standard deviation method gives us this kind of result. So this means that if we give one standard deviation of shock to one sector, how is that transmitted to the other sector? That is what we can analyze from here. Okay. So as we can see, if the response remains within the band, that means okay. If the response remains within the band, that means it is significant. So these bands are basically the red bands are basically the confidence intervals. Okay. So as we can see, from Sensex return to IT return, the shock increases after a certain time period. However, it then decreases gradually. So response of IT return to IT return is high on the first period, which is very natural, and however, it also decreases gradually. What is important is that it takes almost 9 days for the shock to die down completely, and the amount of shock transmitted is very low. So like I repeat, what we can see here is that if we are giving one standard deviation of shock to the residual, what is the impact? So we can say that it is prominent on the first day only, and after that it gradually subsides. However, in this case it is high in the third day and again in the sixth day, and then it gradually subsides. uh, Response of IT return to Sensex return is also like a little high on the eighth day, and then it gradually subsides. So, just to repeat that grandeur causality does not show how shock in one system is transmitted to other system. Grandeur causality that we had done before, it just shows us the lead lag relationship where we came into the conclusion that Sensex grandeur caused IT. Okay. Uh, Now let's do a different form of impulse response. 1 minute. Okay. So we go to view, impulse response, and now let us do residual as one unit. After that, we can also do residual as with a Cholesky ordering. So if now we are saying that if we give one unit of shock to one system, how it is transmitted to the other system. So here we have the results. So like interpretations will be done in the same way. So as we can see that here it is 1. Okay, so which means that if we are changing residual by 1 unit, then on the very first day transmission will also be by 1 unit in the case of IT return to IT return. However, in the case of Sensex return to IT return, it is lower than that. So both Sensex and IT, as you can see, is mostly affected by itself than by the other sectors. We can also do generalized impulses now. So the nature of the shock is actually very important. So we can also do Cholesky ordering. So it's better to do like Cholesky ordering should be from Sensex to the IT. Let's see how is the series then. So it is more or less the same. However, it is very important that we choose the nature of the shock. Now we will do a variance decomposition analysis. View, then we go to variance decomposition. Cholinsky ordering should be like from Sensex to IT, and this are what we are keeping as our format. So we will do it in a table format. Yeah. So here it is. So as we can see that over time, the proportion of Sensex is increasing in the case of IT. However, it is not very high, okay, even till the last day. So we see that IT is actually a very resilient stock, okay. So the proportion of Sensex is rising, although, however, it does not rise that much. And also in the case of Sensex, the proportion of IT rises over time. Okay. Uh, so we should now to construct the spillover index, we should basically take this and put it in Excel. Yeah, so this is where we were doing our analysis. So let us put it on a new sheet. Okay.